So this reaction is between aluminum, which is aluminum foil here, and something we call copper 2 chloride. I have copper 2 chloride here that's already dissolved in some water. Now aluminum foil has a little bit of a film on it to help prevent it from reacting with things like the air. So I'm going to do one where I'm not going to do anything to it. And I'm going to take this one with some steel wool and I'm going to scrape it. Scraping is going to do two things for me. It's going to first get rid of that film, and it's going to create little tiny grooves which increases the surface area. Okay. So now what I'm going to do is I'm going to take the copper 2 chloride in blue, a little bit of solution that's already in water, and I'm going to put a couple drops here and watch the speed of this. So this is not scraped, not scraped. So you can definitely see that the scraped one's going faster. That one is going, but it's a little bit slower. More surface area, same concentration. So now I'm going to take the solid copper chloride. I'm going to put a little bit here so you guys can see what the original color is. And I'm going to put a little bit on here. Now, you might think that you're going to get an immediate reaction there because that's as concentrated as you can get. Hopefully by now you recognize that the more concentrated the solution or the mixture, the more it's going to react. But this is not going to react because it's a solid. The particles of the solid are not moving around. They can't really touch and interact with the aluminum at the right angle to make that work. Now, there are some really smart people that got some solid chemicals to react with solid chemicals, which works in what use your USB drives and a lot of hard drives now in your computers. I think they won a Nobel Prize for that. They definitely deserve it. But if I need to get those particles moving in order to collide with the particles of aluminum in order for that to react. So what I'm going to do is I'm just going to take a little bit of water. This is just a water bottle. I'm going to add just as little bit of water as I can to get as concentrated a solution as I possibly can. But I want to dissolve it all. So there is the unscraped. It's definitely reacting faster than what it did before because it's more concentrated. Got some nice smoke there. Okay, definitely got a lot hotter. And do the same thing with the scraped one. And you should see almost an instant reaction. So you guys can see that it reacts much, much faster with greater surface area, with greater concentration. And you notice it actually went faster in this case because this is an exothermic reaction, so it actually warmed up, which heated it up, which got the particles moving faster, which got it to go even more. And now if you look, you'll see the leftover material is kind of this brownish color. So if you look at what's happening with the reaction, we're taking copper chloride and aluminum, and we're making aluminum chloride and copper. The copper chloride is this blue kind of green stuff. Okay, when it dissolves it in water, it makes the water look really a bright blue. Okay, the aluminum silver. At the end here we have copper, so that brown stuff is actually copper that came from the copper 2 chloride. So this copper replaced the aluminum to make aluminum chloride. And in that liquid down there that you can kind of see, it's actually a clear liquid that is now aluminum chloride. But if I were to clean that out, and I wonder if I can do this, if I rinse that out a little bit, you might be able to clearly see the copper. It's a powder, so it's kind of hard to see, but there is copper powder in there. The other day I was able to get that to actually get a nice, good, solid chunk of copper. But there you go. Chemical reactions. Faster reaction if I have a higher temperature, faster reaction if I have more surface area, and faster reaction if I can get the particles to orient at the same time, which is a different experiment to see. I can't quite do that with this reaction because I would need a catalyst.